Good evening. My name is Alma Mejia, and my team members are Austin Fares and Joe Alverde. We are currently enrolled in the Computer Integrated Manufacturing class, and we're going to talk about our project, which is about a desk organizer. Background. This project presents the complete design, modeling, and manufacturing planning of a functional desk organizer assembly using Autodesk Fusion 360. The goal was to create a compact and practical solution for organizing common desk items such as pens, sticky notes, paper clips, and smartphone. The project integrates multiple aspects of engineering design, including parametric CAD modeling, component assembly, mechanical analysis, CNC manufacturing, and design optimization through design of manufacturing and design for assembly principles. In this slide, you can see the design assembly concept, which include all 6 components, which are the pen holder, the sticky note holder, the phone holder, the base tray, the paper clip holder, and the divider wall. Parts of the desk organizer. The desk organizer consists of 6 unique parts, which are the base tray, pen holder, sticky note slot, phone stand, paperclip cup, and divider wall. Each of these components was developed with manufacturability, functionality, and simplicity in mind. So on this slide, we have all the components. Let me go over on how we created a 3D CAD models in Fusion 360. So for the base tray, we started with the top view. We created a rectangle with the dimension of 200 by 120 millimeters, and then we strewed to create a 15 millimeter height. Then we fillet all top edges to 3 millimeters, and then we created the pockets for each of the components for proper alignment. As for the pen holder, we started with the top view. We created a circle with a diameter of 40 millimeters. We extrude to create a height of 9 millimeters, and we created a shell to create a wall of 3 millimeters. Then we fillet the top edge with the 2 millimeters. As for the sticky note slot, we started with the top view. We created a rectangle with a dimension of 80 by 80 millimeters, and then we strewed to give it a height of 10 millimeters, and then we created the pocket. As for the phone stand, we started with the side view. We created a rectangle of 70 by 60 millimeters. We extrude 50 millimeters to create that width. And then we created a diagonal face cut of 60 degrees angle. And then we grooved the base. As for the paperclip cup, we started with the top view. We created a circle with a diameter of 50 millimeters. We extrude to give it a height of 30 millimeters, and we shell the wall thickness to a 2.5 millimeters. As for the divider, we started with the front view. We created a rectangle with a dimension of 120 by 40 millimeters, and we extrude to give it a thickness of 5 millimeters.
Hello, hi, my name is Joe Alverde. I'm going to be covering the manufacturing plan for the part. We've broken this section down covering the base plate portion or piece of the manufacturing design into a couple of categories. One starting off with the part overview, next the material and setup, following the sequence of the process, and also then covering tool paths and tools. When we go back and look at the overview here, we can see that the base plate is a flat tray comprised of both circular and rectangular pockets for the design. The design here, we're going to be using a 3-axis CNC milling tool to actually manufacture this part. And as far as dimensions, this dimensions here is going to start off at 180 millimeters by 120 millimeters by 15 millimeters. As far as the material and setup, an ABC plastic or aluminum 6061 can be used to manufacture this design. followed by the machine of the 3-axis CNC mill. And as far as the stock setup, we're doing the WCS at the top left corner. The sequence, we follow the sequence in this order, starting off with the face top, adaptive roughening, pockets and contouring, and then finishing. An optional chamfer or scallop, which will be covered later in the presentation, could be set up. As far as the tools and tools pass, for both operations and tools, the face, we're looking at a flat end mill, 12 millimeters. Adaptive clearing, we're looking at an 8 millimeter flat end mill. The 2D pockets manufactured using a 6 millimeter flat end mill. 2D contouring is using a 6 millimeter flat end mill. The optional chamfer will actually use a chamfer tool, and that'll be covered later in the presentation. And an optional scallops is a 4 millimeter ball end mill. Thank you.
The DFMEA considerations are the following. We selected a standard tool diameter of 6, 8, and 12 millimeters for accessibility and cost efficient. We also added a corner die to allow tool access and reduce stress concentrations. We consolidated the pocket depths for fewer tool changes, and we ensured flat button pockets for easy cleanup inspection. After a few discussions, we came up with the following modifications to the model. We will be adding chamfers on the edges to avoid injuries from having sharp edges. As for the divider, we're going to be utilizing as a multi-purpose wall that also acts as a ruler. And for the phone stand, we're adding a charger for when your phone is stored on the stand. So here's the final list of the desk organizer, with the 6 unique parts. The base tray will be modified as previously mentioned, with the chamfer added to the edges to avoid potential injuries. The pen holder is going to stay the same for the sticky note slot. As for the phone stamp, we are adding a built-in charger. The paperclip cup will remain the same. The divider will also be utilized as a ruler, so this one will have a change. Each component was developed with manufacturability and functionality and safety in mind. So here's a picture of the 3D CAD model of the base tray with the chamfers added on the edges to avoid any potential injuries. Here's a picture of the divider that also can be purposed as a ruler. In conclusion, the updated desk organizer maintains its essential functionality while effectively achieving the project's goal. The product is safer, simpler, and more effective as a result of careful use of DFM and DFA concepts. Even though the improving functionality wasn't the main goal, it was inevitable to produce a number of enhancements. Future iterations might investigate the possibility of greater improvements. Thank you.